Yesterday we did a full-blown linear regression t-test. Realistically, it's not what it's going to look like. And I think it's just because of the weirdness with the calculator, not being able to plug in the standard error and things like that. So this first page that you guys have in front of you is explaining the different parts of the computer printout, most of which you guys have seen, where the y-intercept is located, where the slope is, the standard deviation of the residuals, and that is important, that S is, it's not the standard deviation of the slope, it's of the residuals. There's your R squared, and then we've got these new numbers that are coming in. And because linear regression is based off of slopes, you'll notice that everything that I'm referring to is about the slope line. The constant is the y-intercept, the number next to the miles, that's the slope. This is the standard error of the slope. This is the t-value of the slope. This is the p-value, well, when you're doing a test for slopes, this is the t and the p-value. And that explains it right there. Okay, so this page, I'm going to leave you guys do that by yourself. That is, can you interpret these things from the computer printout and make sure you know how to interpret them. So it's a good review from Chapter 3. Now if you turn it over and go to the next page, this is something that we can expect to see on a quiz, maybe AP exam. So what does it look like? We want to do a significance test to see if time is useful in predicting tips. So they want you to write the appropriate null and alternative hypothesis. So let me start by getting the equation of the least squares regression line. It looks like they're trying to make predictions for tip, and the coefficient of the constant, that's A, plus 0.03013 times time. Okay? And so notice these are the coefficients, the y-intercept and the slope. Slope is next to the explanatory variable, which is time. Make sure it's got a caret. So now we're going to write our appropriate. So HO for this test is that beta is equal to 0. And you have to write in words. There is no linear relationship between time and tip. The alternative is that beta is not equal to 0, and there is a linear relationship between time and tip. That's what you're trying to find. So, and this is why I kind of went through yesterday, is if you notice, and I'm going to circle, this is the slope line. So if you even just go to the second line, slope, focus on that. Those are the numbers you're going to use. So yesterday we looked at the formula to find the t statistic here, and it was beta, b minus beta over the standard error of the slope. Okay? Well, then it turned out that beta was equal to 0. And so what happened is t is equal to b over the standard error. And likewise, you can solve for standard error, and that's equal to, I don't know why I drew that, b over t. We'll just, sorry, there should be a box around that. So this is nonsense. I don't know why I drew that. Okay, so knowing what we look at, t is equal to b over standard error of the slope. So t can be found by taking b, which is the slope, 0.03013, divided by the standard deviation or the standard error. They might use either language, I'm not sure, but that's of the slopes, 0.02448. And when you do that, you will get a t-value of, I don't know, I've got to type it in, 1.23. 0.02448. Okay, how many degrees of freedom? Well, yesterday we learned that because it's two variables, it's actually n minus 2. So I got to go up here and look up. They did 12 receipts, so 12 minus 2 is 10. Okay, so now this is weird because, again, the p-value for the two-sided test is left out. And it's really important that you guys know that this is always a two-sided test, at least in the computer printout world that they give you. That's just the default to it. So here's what's happening, okay? Beta goes in the middle, that's 0. You assume there's no linear relationship. We found the t-value for the slope. The slope was 0.03013, and the t-value for that value was 1.23. So you're over here, shading to the right, but you're also shading below the same distance. So this is a two-sided test. So what you do is you go into your calculator to TCDF, and you're going to type in the t-value, comma 999, but also the degrees of freedom. So for our problem, 1.23, sorry, I'm getting sloppy, 1.23, comma 999, comma 10 degrees of freedom. So go to the distribution menu, everyone. Second, vars. And I'm going to TCDF. You're going to type in the t-value, which is 1.23, comma 999, but you also have to give it the degrees of freedom. And that's going to spit out a p-value, 0.123. Now look at the picture. 1.23, comma 999 gives us this area. We need this area too. So hopefully you're thinking we should multiply that by 2. So I'm going to multiply that p-value, t-value, multiply that probability by 2. So just by 2. And our p-value is 0.246. So that TCDF gives us this area, but we want double that area. So here we are at 0.246. Okay, so write our conclusion. Since the p-value is greater than alpha equals 0.05, we reject. No, we don't. We fail to reject HO. We are pagaffering. There is not sufficient evidence to conclude there is a linear relationship between trying to abbreviate and then I don't, between time and tip. Getting very sloppy. I apologize, everyone. So p-value is large, it's greater than alpha. We fail to reject HO. Not sufficient evidence to conclude the alternative that there is a linear relationship between time and tip. Now if we wanted to create a confidence interval, the formula for the confidence interval is you start with beta, B, you don't know what it is. You add and subtract the t star times the standard error of the slope. Okay, that's, remember the visual here. The sample goes in the middle, plus or minus how many standard deviations. Your job is to find these numbers. From page 5, statistic plus or minus critical value times the standard deviation of the statistics, which is of slopes. So we're going to take our B, which is 0.03013, that's a sample slope, add and subtract our T star. I have to find my lime sheet. So 95%, 10 degrees of freedom is 2.228. Times the standard error of the slope, which is given in the computer printout of 0.02448. Okay, and so I have to add and subtract. So guys, notice, this says standard deviation, but really you kind of swap out standard deviation, standard error. Everything is about the slope. This is little b, that's from the sample. This is the standard deviation of the slopes. This is the t-value for significance test for slopes, p-value for slopes. So everything is that second line. So now you're just going to have to type those numbers in, add, and then subtract. And pending I did not make a mistake, 0.02448. Okay, I'm getting negative 0.0232 comma 0.085. So we interpret our confidence interval. We are 95% confident the true population slope of the least squares regression line for time on tip is between negative 0.0232 and 0.085. Now notice, what's interesting is, do you see how 0 lies in the interval? So if 0 lies in the interval, and we're 95% confident that it will be there, do you see how we did fail to reject the null hypothesis because 0 is in the interval? So that's how you can relate your significance test results to your two-side test results to your confidence interval. So let me put that back up there, and hopefully that's ending it for that. I think this is my last video, guys. Hopefully I won't be back, but maybe I will. Hope you guys have a good rest of the year if I don't see you. And but maybe we'll have some more when we start reviewing. So have a good day. Bye.